today. Welcome to everybody for joining us this morning. My name is Maruya, and as Eric mentioned, I'm a scientist at the Southern California Coastal Water Research Project. We're located in Orange County, Costa Mesa, in Southern California. So today we'll be talking about an effort that SCWRP facilitated really on behalf of the State Water Board in prioritizing what we call CECs, or Chemicals of Emerging Concern, in receiving waters throughout the state. Now, for those, probably most of you are familiar with how we refer to CECs, but really the definition is any chemicals that are currently unregulated or unmonitored for statewide. And we realize that some compounds that we will discuss today have been the subject of special studies or even regional monitoring programs, but really this effort was, again, on behalf of the state to provide statewide recommendations. So a little bit about the origin of this effort. What we, in essence, did at SCWRP was convene and manage a panel of experts. And the reason that we needed these experts is really stated in the second bullet. We know something about CECs. We know a little bit about their occurrence and probably a little bit less about their potential for toxicity in receiving waters. But that body of knowledge is really incomplete and at the start of this whole process. So we need to be current. We need to base how we move forward with monitoring and regulation in receiving waters based on the best available science. And so it's really important to weigh in with the experts to see where we are on CEC. So with that, we were tasked to, again, convene an advisory expert panel to make recommendations, first of all, back in 2009 on recycled water applications throughout the state. And as part of that process, we took advantage of this panel, the convening of the recycled water panel, to extend their charge to receiving waters throughout the state. And that's what we'll be talking about today. Clearly, the panel needed to address the questions that are most relevant to managing these CECs in our waters, and we'll get to those questions in a later slide. The panel selection process was guided by a group of stakeholders. We wanted to make sure that we had the very best experts and also that we had a balance of unbiased experts. Very important that the stakeholders have confidence in the members of this panel, that they could look at the science in an unbiased nature. We had the fortune of, again, taking advantage of a 6-member panel that was convened for recycled water applications. We retained every single member of that panel, and then we also identified the need for additional expertise in marine resources. And fortuitously, it turns out that we also got an expert on antibiotic resistance, which is an issue that has come up in both applications. We were able to convene this panel starting in the beginning of 2010, and they finished their final report last summer. A little bit about the governing principles and philosophy of this entire effort. We wanted, first and foremost, to make sure that the process was transparent and open to commentary, scrutiny, and input from the stakeholders and the general public. Very important that we achieve buy-in, or at least we're able to communicate the nature of the panel to those interested parties. To do that, we needed some point people throughout the stakeholder community. We reached out to 3 different communities, public interest groups, the discharger community, the regulated community, and also the regulator community. So we wanted to make sure that that triumvirate was well represented, again, from the statewide perspective. We allowed for public comments and interchange with the panel at every one of our 6 meetings. And again, the charge was for this not to make policy, but to provide the science to inform the policy. Here's a list of our stakeholder advisors. As you can see, we had a pretty good mix of, again, the regulator, and the NGO communities. And we also got a pretty good split of north versus south geography. So we were very happy to have these folks help us communicate their issues and needs and to report back to their constituencies. The panel members are listed in this slide. Again, I mentioned we had an original 6, and those are the people. Those are Paul Anderson, Nancy Denslow, Jorg Drevis, Adam Olivieri, Dan Schlenk was the chair of the Eco Panel, and Shane Snyder. These folks served on the original Recycle Water Panel. They were familiar with the data sets available on some of the discharges in California. We added Dr. Jeff Scott from the NOAA lab in Charleston, who did really double duty. He served as a marine resources expert, and also his lab is very active in looking at antibiotic resistance in discharge environments. One other note about this panel, as opposed to the stakeholder group, we intentionally went out of state to get many of our experts. We didn't want to have too much of a California bias on the science side. So this group represents really a national pot of expertise. The charge that was given to the panel is delineated in these several questions. Clearly, the question of most interest is that second bullet. What's the list of CECs that we need to really look into in the future? But in answering that question, we needed to address several issues that were above and beyond really the recycled water effort. That was a very focused effort on human health and 2 or 3 recycled water applications. When we get to receiving water discharge, now we have a more general discharge scenario to deal with. We've got multiple sources to consider from the permitted side, both wastewater treatment, plant effluent, and stormwater. The other thing is that the receptor side or the effect side is a much different situation. We're talking about ecosystems now, so we worry about fish, we worry about marine mammals, we worry about even microbes and invertebrates. So a broader range of potential receptors and effects.
Keith?
Yes?
It's becoming harder to hear you.
Okay. Is this any better?
Yeah, that's much better.
All right. Sorry, I just have to hold the phone a little closer. Okay. So in their deliberations, again, the panel met 6 times over about a 2-year period. And what they did was not just create a list based on existing data. What they decided early on was to provide a tool or a framework that the state could use now and also into the future. So a framework that can be updated with current data. And this framework we'll get into in a little bit. It's a risk-based framework. The second product that they delivered was to turn the crank on this framework with existing data. So we mined a lot of the existing California discharge data and receiving water data, as well as a toxicological database. And we turned the crank on this framework to spit out an initial list of CECs that we need to start that monitoring process with. The third product was actually some guidelines on how to design a CEC monitoring program statewide, the how, the why, the where, and the when, and then the methods to use that. And then finally, because the state of science of CECs is incomplete, a very important part of their charge was to look into the future and make recommendations on where we needed to take monitoring and to fill data gaps on CECs to improve the protection of our resources from CECs. Okay, so product number 1 was this screening framework that I mentioned in the last bullet. really a very traditional, simple risk-based paradigm where we marry both the exposure side through measured concentrations. That's the first bullet, what we call MECs, measured data, or even predictions from measured data when we say we model a dilution or estimate a dilution from an effluent. Important from the exposure side to have good knowledge of what occurrence is out there. The second piece of information that's important for the risk paradigm is on the effects or toxicological side, and we coined this term deriving what we call a monitoring trigger level based on that toxicological information. And we simply just married those two quantities to come up with a monitoring trigger quotient in step 3. And it's very simply, if that trigger quotient, in other words, the exposure exceeded what we considered to be a good threshold, then we added that chemical to a candidate list. If that quotient was less than 1, then we did not consider it further. Because there are many, many discharge scenarios in the state, we wanted to capture what we considered to be the major or all-encompassing scenario. So the panel decided on these 3 scenarios that, again, captured many of the discharge scenarios in the state. First one is an inland waterway, a freshwater system, where during summer, pretty much the effluent discharge comprises about 100% of that flow, so very little or no dilution of an effluent as the source of the flow in the system. The second scenario is an embayment on the coast, where you have now both sources. You have effluent originating either upstream or actually into the bay, for example, San Francisco Bay. But you also have runoff from the margins of the watershed as stormwater. And in this scenario, we had to consider some dilution based on the connectivity to the ocean. The third scenario we have mostly in Southern California, where we've got very large wastewater treatment plants discharging onto the continental shelf in deeper water. You achieve greater levels of instantaneous solution, but again, you are discharging several 100 million gallons of wastewater a day in this scenario. So in applying the framework to those scenarios, we had to mine the existing data. We had to look for high-quality occurrence data and create a toxicological database for these receptors of interest. And if you look at the third bullet, we're not really concerned with acute effects for many of these CECs. What we're looking for are chronic type effects, reproductive and endocrine modulating type responses for organisms such as invertebrates and fish. So very few acute endpoints come into play here. We're looking for no effect and very low effect level concentration. To add to that conservatism, we considered only the maximum concentration on the occurrence side, and again, we used that framework to marry those 2 concentrations. When we were able to create a list, it was very important in the last bullet to make sure that the methods used to achieve these occurrence data were robust enough for the panel to be comfortable listing these compounds. So there needed to be a paper trail on how these methods perform. So getting to the list, for that initial run-through of the framework, we had a variety of classes of CECs represented, and as you can see here, pesticides, some chemicals of general, commercial, and industrial nature. The natural hormones made the list. And then the last category that was included from the waterborne side anyway was an antibiotic triclosan. That's the antimicrobial agent added to many hand soaps. That particular compound was included, again, for antibiotic resistance effects. Now, CECs can have different properties in the environment. The last slide showed chemicals that we expect to exist in water. Other chemicals, based on their properties, will not occur very high in water, but they will partition to sediments and actually accumulate in tissues. And this list of compounds illustrates how the CECs differ in behavior and which compounds, such as PBDs, the flame retardant, and the perfluorinated chemicals that you may have heard about, might accumulate in tissue. So we're on the lookout for these compounds in different matrices. So that is what the list of CECs that are recommended. When we achieve or compile these monitoring data, what are we going to do with it, and how are we going to interpret it? That is something the panel spent some time on, and basically what they concluded was, because the nature of CECs changes yearly or in cycles, we need to be able to adapt and respond to that changing chemical environment. So that entails including interpretive guidelines where you're able to de-emphasize a listed CEC and conversely identify future CECs that should be incorporated into the monitoring process. And the way the panel chose to do this was really to create this framework of interpretation where we're gathering the occurrence information. We can estimate those trigger quotients on a cyclical time frame and adjust as needed based on the value of that trigger quotient. If we continue to see trigger quotients on the order of 1 or even higher, of course we need to take the appropriate action to deal with that. On the other hand, if there's very little evidence that that trigger quotient poses a risk, in other words, much less than 1 in a few cycles, then it probably gives us the firepower to delist that compound. On the on-ramp side, there are 2 ways the panel recommended in looking to the future and making sure we're not missing important chemicals. One is to continue with investigative or special study monitoring as methods develop for new CECs. An example of this would be something like the chlorinated phosphate flame retardants that are replacing PBDs. We see indications of increasing levels in the environment, and that's something we need to keep our finger on. The second method to have an on-ramp for chemicals is really to enhance the use of modeling and to predict the occurrence and effects of newly produced chemicals. And this is a longer-term effort where we need to consider source inputs, production, usage, fate through treatment plants, and in stormwater conduits. So it's a very involved and linked process, but one we think will be very fruitful in the end. And again, the interpretive framework that we showed in the previous slide can be used with these exercises as well. Look at this periodically, whether it's a cycle of 3 to 5 years or even a little bit longer, and adapt to what the new information is saying. In terms of the future technology and recommendations that the panel identified, this is really the main one, and this is what Dan will be talking about in his subsequent presentation. Because there are so many chemicals and the development of methods and the accumulation of toxicity information cannot keep up with commerce, really, in the production of new chemicals, the panel saw that there needed to be a more efficient way to screen for large numbers of CECs. Some of them known, many of them unknown. And the whole concept of using in vitro bioassays that were developed for high throughput chemical screening by EPA and others is really the approach that the panel thought had the most promise. So moving forward, CECs are a moving target. We need to continue to accumulate the best monitoring data we can and adapt to that information using this interpretive framework. It's very important to do this on a regular cyclic schedule so that we're keeping up with the changing chemical environment out there. As you'll hear from Dan, we were putting a lot of emphasis in turning the monitoring approach sort of on its head, looking at a different way to screen first for chemicals by using biology as opposed to individual analytical chemistry methods. It will help us integrate exposure of multiple chemicals, so it helps us with mixtures as well. And we think that by incorporating this screening, we can be much more efficient and utilize even our targeted tools better in this tiered framework. We have since been contacted by SWAMP to help the state develop a CEC monitoring plan statewide. This is really fleshing out the panel recommendations to the next level of detail, and we hope to do this in the next several months. I'll leave you with this slide. This is really the vision for the future for monitoring that we see it at SQUIRP anyway, with that screening step as really the first level of monitoring. If we see responses, then we can utilize that information to direct different chemical and biological monitoring approaches or evaluations. We feel that this is a much better, much more comprehensive and a much more efficient way at getting to the real answer, whether our receiving waters are safe or not. So with that, I will stop, and I'm happy to answer any questions that you all have.
Thanks, Keith. We can take a few questions over the phone. You press *6 to unmute. You can answer your question, and you can also send your questions via chat. Hey, Keith, we have a request to see the slide with the list.
All right, I'll go back.
And we also have a question. Are juvenile freshwater mussels, they're found to be sensitive to water contaminants. Do you know if this group will be used to study toxicity of the CECs?
Okay, so here is the list, but I'll address the question, and then I'll also defer to Dan to see if he has anything to add to that. Bivalves are an important sentinel. They've been used both historically and currently to assess water quality. We don't have specific plans to incorporate bivalves in a statewide plan, but that's not to say that we're going to exclude them. As part of the data gathering exercise, we actually were involved with a pilot study statewide that was part of the national NOAA Mussel Watch, and we analyzed over 300 different CEC analytes in mussel tissue at about 70 stations on the coast. So it is a very important sentinel organism or class of organisms to consider, not only from the chemical side, but also to look at the biology of mussels using advanced genetic and biomarker tools in these mussels to see what the effect of their environment is. So,
yeah,
Dan, I don't know if you want to add on that.
Sure, I'll add a couple things on. Toxicity, really, if that's the question, if I'm reading the question correctly, toxicity is obviously a outcome of exposure and effect. So what Keith's been mentioning in terms of the mussel watch for marine system mussels has been primarily for an exposure assessment to see whether or not the compounds are moving, can move in the food chain and are actually being there for consumers of mussels, for example, to eat them and things of that nature. So it's more of an exposure side. And then with regard to freshwater mussels, again, one of the things we highlighted in that report was the paucity of data for tissue residue analysis for most of these compounds. So, anything that could be any sort of tissue residue analysis in any species, whether it's mussels, fish, any sort of organism that we could have a method to determine those compounds would be very, very useful. From the effect side of things, the way that we did this in a risk-based approach is we used all the data that we could find in terms of all organisms. So we split that up between plants, invertebrates, and vertebrates, as well as avian and mammal species to even extend that a little further. And, some of the compounds had mussel data, if I recall. I can't remember the exact which ones had mussel data in terms of mussel toxicity effects. I would say most of them did not. So again, the idea to use the effect side of that risk equation, you would have to identify data where mussels were actually exposed to those compounds, and you got some form of threshold value to compare against the exposure that you would be seeing to that compound in that particular waterway. So, in terms of toxicity of mussels, you've got to look at both of those factors, exposure and effects. And I have to say, there's just not a lot of data, even with legacy compounds for mussels. They've been a topic of huge concern throughout. I know at least through CTAC we see presentations and sessions devoted to unioid mussels and particularly in freshwater systems throughout, trying to get a handle on them because they are such good indicators of water quality.
So two other quick follow-up things. The list that you're currently seeing on the screen were analyzed as part of that Mussel Watch pilot study I referred to. Most of these waterborne chemicals aren't going to show up or accumulate in the mussel. That's not to say that they're not going to have an effect. You need a different endpoint or way to look at the effect side. But if you go to the next slide, the study really corroborated the recommendations that the panel made on what accumulates. The PBDs and the PFCs did show up in mussels in addition to some of the industrial chemicals. So using those programs will help vet any listings or recommendations made and can, again, be used in that off and on-ramp scenario would be very valuable.